right, ladies and gentlemen, so today we're going to take a look at how we can do these lines of best fit on our calculator. So you are going to need your calculator handy in front of you. So these are called linear regressions when you do it on the calculator. And we actually did these earlier in the year when we were first learning how to graph things on our calculators. But let's see here. So we have a survey. We did this in our last lesson. Now we're going to take and do it on our calculator. So I want you to take a second, and I'm going to pause the video as well. But I want you to enter in list 1. I want you to enter the low temperature, and in list 2, I want you to enter the high temperature. And then we'll come back and talk about how to do this. Okay, so now that you're going to do this, so now I'm going to actually show you how to do the scatter plot. So in order to create your scatter plot, first of all, we do need to change our window. So now that you have your information in the list, if you go to window, and you want to change it because if you look at our minimum and maximum, you can change these because you don't want it to take up this big amount of screen. So my lowest X temperature, I believe, is a 26. So I'm going to set my X minimum at 25, and I'm going to have it go up to, I don't know, I think I'm going to have it go up by maybe 2s. That sounds about good. So again, I'm going to change it, and you just have to hit the window button, and you're going to change, the maximum, the maximum needs to be 45, and we can go up by 2s. And then our Y minimum, we have the lowest numbers of 49, so I think I'll set my Y at 45. Highest is 72, so I'm going to go up to 75, and again, I'm going to go by 2s. Okay, so you need to set X min, X max. You need to set the scale, which was 2, and then I did the Y. To now get to creating the scatter plot, you're going to do stat plot, which is second Y equals. And you need to turn the plot on. So stat plot 1, if you hit enter, and you're going to turn it on. So stat 1, and then turn it on. And then you're going to pick the type. And the type that we need is just the first one. Okay, and so you're going to type, and you're going to do type, and you're going to enter on the first. And then you hit graph. And it's going to show you a scatter plot. And it asks you to kind of go back and compare that. But you're going to see that you're going to have this line this trend line in there. Okay, now let's talk about how to do this. So in order to do our line of best fit, our equation, we're going to do stat and then calculate. Right, so you have to go over to calculate, and then it's number 4, which is linear regression. And I know that because it looked like a straight line when I did my plot. And it's going to tell you information. It's going to give you the general form, ax plus b, and it's going to give you values for a and b. So our equation then, if I fill in a and b, and it asks us to round the slope to the nearest hundredth, so that's your a, 1.16, and your y-intercept to the nearest integer, which is going to be 19. Okay, if I compare that, when I did lesson 6, and we did our slope, we had 9/7, which is about 1.28. Oops, nope, down here. So my slope from the other one is 1.28. So we're pretty close. And again, if I had moved that line, it might have been even closer. Explain what the y-intercept of this model represents in terms of the low and the high temperature. And it's the same thing as we said before. When the low is 0, the high is 19. That's what your y-intercept is. Let's see here. How would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? Same idea as before. So as for every degree the low goes up, the high goes up 1.16 degrees. Okay, so let's take a look at the second page here. And again, this is just really calculator work. So I'm going to pause the video. I want you to enter it and see if you can find the equation of the line of best fit, rounding, and then, create a scatter plot. We're just going to sketch that, but pause it and then come back and check your. Okay, once you entered it, you should have gotten an equation of negative 8.1x plus 68.1. They wanted to know what the x and y represent. X is the weight of the car in thousands of pounds. Y is your miles per gallon. Create a graph of the scatter plot. And you did have to go back in and change your window because you were dealing with different values. But then once you changed your window, you just had to hit graph because we already had stat plot on. This is a very crude drawing of what it looks like. I didn't have much room there. Would you consider the correlation between weight and mileage to be positive or negative? And explain it's negative because as the weight increases, the miles per gallon decrease. Let's do C and D together here. So which parameter of the linear model predicts whether the correlation is positive or negative? That's your slope, right? Your slope is going to tell you that. When it's negative, when slope is negative, the correlation is negative. Right? So that's what's telling you what type of correlation you have. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency? So you're going to now use that equation that you have, and because we're talking about the weight of the car, you're going to fill that in for your x value to find y. So negative 8.1 times 4,300 plus 68.1. And when I did that on my calculator, it asked to round to the nearest integer. So that was 33 miles per gallon. Turned out to be 33.27, so that had to round down. If we wanted to purchase a car that got 40 miles to the gallon, what weight of the car? So now this is y, and we're going to try to figure out the weight of the car. So we have 40 equals negative 8.1x plus 68.1. Now we have to get x by itself, so we're going to subtract 68.1, which is going to give me negative 28.1. Divide by negative 8.1. Oops, don't need that x there, sorry. Divide by negative 8.1, which gives me, when you do this, you're getting 3.5. But what you have to remember is that's 3.5 thousand, which means the weight of your car is really 3,500 pounds. All right, so again, it's about knowing how to use the technology that we have, and more importantly, knowing what is all of this telling us. What is the y-intercept, what is the slope telling us about this problem? And there is a pretty good example. As always, any questions, bring them with you. Have a good night.